Hi, welcome to Make a Repair. Today I'm looking at something for a friend, and it's this Ring automated air pump and emergency light and things like that. And obviously it plugs into the power supply in the car and can pump your tyres up and things. So apparently this is not working. You can see we've got a big flashlight and emergency light on that side, fitting here for the car, and then we've got our compressor output just here. So all very neat. Let's see what it actually does. I'm going to have to power this from my lab supply. So we'll power on. Our little blue thing here has come on. So no signs of life from the pump. Turn on to light, and the light works. It's not very bright, but it's definitely there. And I'm drawing a tiny amount of current, perhaps 50 milliamps, something like that. Flash. Flashing isn't working. SOS. No, that's not working either. So the only thing that works on there is literally the light. It's not exactly bright. And nothing's happening here at all on the control panel. I don't know exactly how this works. There is, I think, an instruction book. So I'm absolutely expecting to be able to set pressure on here, and nothing's happening at all. Literally the only thing that's working is the light setting, and that works whether it's turned on or off. So yeah, okay, let's have a look, see if we can find something. So it just uses some Phillips screws, I think. I can hear something rattling in there, which is always disturbing. So these screws are just self-tapping into the plastic, and I have noticed some cracks in the plastic as I've undone them, and it has become a little brittle. And in some ways that makes life easy if it all falls apart like that. And here's our pump mechanism. And here's our light mechanism just with LEDs in it. And we've got a little relay next to it. And then we have it. So here's our circuit board. There's not much on it. This red and black wire go off to the power switch. This thick wire here is one of the inputs from the power supply, and this is the other one. So that's the negative going into the middle of the board, and the positive is coming into the edge of the board. This board has just got some LEDs and the driver relay for the pump, so I'm going to need to look at the other board and try and map out the circuit to an extent, just to understand where everything's driven from and things like that. Okay, so I've taken out the main processing board. Here's our LCD display. Fits on using this little zebra strip onto this set of contacts just here, and here's our backlight. So our backlight is working. We can see that when we turn it on. And unfortunately we've got a blobbed IC down here. So I'm just going to get my magnifying glass. We've got a 24C002A down here. That's a serial EEPROM, probably just storing user settings. So I'm going to trace the power from the adapter all the way to this IC, because I always need to know that power is getting everywhere it should. Now that will either reveal the microcontroller to be faulty underneath that blob, or something in the power side of things, perhaps just one of those discrete little components like the 0 ohm resistor or something. Could just be faulty. Anyway, we'll trace it through. So it looks like the power transfers across the main board on this cable just here. So our 12 volt goes in onto this board here, which has got all the LEDs on it as well. And then it must be transferring potentially with a bit of step down, I guess. Although I'm not seeing anything obvious to do that. There's no regulator IC, a couple of transistors, but I suspect they're to do with driving this relay. So the power goes onto this board, lights the backlight, powers the IC. So as soon as you connect this into the car, then it should start displaying stuff, but all it does is light the backlight up. So I know I've got power at least coming onto the main board. So we've also got a pressure transducer tucked down here on this pipe, which of course is teeing into the outlet of the pump just here. The pump obviously just going out to the connector there, and the pump is literally just a motor connected to the actual pumping device. That is driven by that relay. Now in series with the relay is the on-off switch. And we've got a multi-way switch here, which is just signaling this board to say, I would like the LEDs on, I would like the LEDs on constant, I'd like them on flashing, I'd like an SOS signal, that type of stuff. So I'm assuming this isn't a transistor, there's probably a voltage regulator. Let's have a look at the number on it, so you can see. It is actually a 7805, I think, regulator. So one end or the other must be connected to positive shortly. We've got 200 ohms. Okay, so finding that voltage regulator has really kind of filled in the missing pieces. So I've been tracing the 12 volts through. So here is our 12 volts. And we can see, first of all, that it goes straight up to the multi-way switch. And if we select the light setting, it comes straight down through this white LED and lights the LEDs and creates the light. So that's really, really simple. It's completely isolated from the microcontroller and everything, which is kind of why it's still working. Now the on-off switch is down here. And we can see the 12 volts goes through that, and it's in series with the relay contacts and the pump. It can permanently disable it so the relay can have no effect, or we can enable it so the relay can turn it on and off. All this 12 volts is happening on the LED and relay board. That's where the power comes into, and that's where all the big switches, the external switches, connect to, all with cables and things. It's unbelievable. I have no idea why they would think to make it like this. It's like throwing money away in the factory process. Anyway, this 12 volt also comes off the board and heads across to this second board, which is actually sort of the keypad and the display and what have you. And this is where all the logic and all the control happens. The first thing we can notice though is that the 12 volts go straight up and straight to the backlight. It does not do that via a controller or a regulator or anything else. So again, that's why the backlight is working, because it's connected straight onto the 12 volt line. Now, it took me a while to trace this 12 volts through to the regulator, and that's because there was it's a 402 size resistor, absolutely minute, 220 ohms in series with this regulator. Yeah, I wasn't expecting that to be there. It took me a little while to find the signal running through there. So I tested the 12 volt all the way up to this 7805 regulator. And that, of course, is providing 5 volts for the microcontroller, the EEPROM, the display, the LCD, and anything else that wants to be on 5 volts, the pressure sensor, for example. So we've got the 5 volts coming out of that, powering everything. Then the microcontroller controls everything else. It obviously reads the 3 little switches that are on the panel. It controls the pressure sensor, or reads the pressure sensor. It can control the flashing red LEDs, because the rest of that multi-way switch up at the top, unbelievably, comes onto this first board with all the relays and things, all the big stuff, and then a cable comes from that board and just transfers them across to the controller. So they're just signals to the controller. They've probably just got resistors in because there's a bit of a high voltage. And yeah, of course, the microcontroller controls the relay, it controls the flashing LED, it can spell out SOS, and all of that type of thing. That results in the pump running and air being produced. So that's it. So what I need to do now is I need to look at the 7805 regulator, make sure I've got 5 volts coming out of it, and then I can trace that through and see if there's any faults in the circuit after it. Hopefully that will be the case, because if it's the microcontroller, then there's no chance. Let's have a look at the voltage output of that regulator, see if it's got an output. That's a obvious thing to check, isn't it? So we're on, there's our backlight, the center to the side, and nothing. There's my input, 11 volts. There's my output, absolutely nothing. Well, let's try a new voltage regulator. Could it be this simple? Of course it can't be that simple. I've just been through every regulator that I've got, and I haven't got that one with that pin out. Unbelievable. So I've had a huge hunt around through dozens of boards that I own. Almost all of them have full-size 7805 regulators on them, not this tiny little TO92 package. So I'm thinking I might get away with fitting a full-size regulator, actually attaching it on this board face here, just wiring it back onto here, maybe moving that capacitor to make a bit of space. I think I can get away with that, but before I do that, I'm going to just double check and make sure that regulator is the problem. And I'm going to do that by taking it off and applying 5 volts and seeing what happens. Okay, old device out. Tack a little bit of wire into that pin there. Okay, I think we're about ready to go. And there we have it, an actual readout. So definitely that regulator. Now we just need to figure out if I can do something to replace it with something else that will fit in the box. And then also I noticed there's some problems with these LEDs on this board down here, so I will need to attend to that as well. You know, I am wondering if I can just literally do that and bend that tab back, whether that will actually give me sufficient clearance. Let's get it soldered in and check it works. It's a bit over the top this soldering iron, but the tip is really big, but never mind. I think it's just there. Hopefully that's good. There we go. And we're up and running. Excellent. So now all I need to do is see if this will go in the box. We'll put the display in its little holder at the bottom there. It's sitting around about the right place. Just cleaning these contacts in case they've picked up any rubbish from my fingers. So this is another case of the usual rule, which is I shall always check voltages. All I've got to do is get everything to line up. There it is, we're in. And get those screws back in. Excellent. Feels good. So I'm just going around the LCD at the moment. What I might do is add a little bit of silicone in a minute or two just to secure some of these pieces, although I don't think they really need it. So I've got my new voltage regulator in just here, and it seems to be pretty much clear of everything. I'm pretty happy with it, in fact. Just lean it forward a bit so it's away from this tube, and that's it. And I've started putting things back generally into their rightful places, trying to just figure out what's going on. Now I'm just going to tend to an LED on here which seems to have come loose. I think it's pulled the tracks off, so I'm going to have to scrape back some of the solder resist from that track and see if I can't resolder this LED. I might take the LED out first. I think that might be a good idea. Okay. So I'm not sure how well this is focusing, but just here there are two holes for the LED. One of them, the track is missing. The other, yeah, the track is broken. So yeah, missing track on both of them. So I'm going to scrape back the solder mask and do my best to reattach that LED and remake this circuit running through here. I might have to just put a little bodge wire in or something like that just to help it along. And hopefully that will do it. Right, let's have a look now. Yep, that one's lighting. Excellent. Okay, so I think that's sorted. So I decided not to subject you to the next hour or so that I spent just trying to get it all back in the box. It was an absolute nightmare. Cable routing very awkward, and also the air pipes and things like that all in the way. But I got there eventually, so let's take a look. And I think I'm lined up, apart from the fact that I've got to put the feet on. Come on, part just enough to put that foot on. One foot in. Two feet in. That's coming out the right way, that's coming out the right place. Let's just see if it'll work. It helps if you plug the right connections in. And there we have it, it's alive. We've got 0 PSI. the pump works, bar, kPa, psi. Yeah, and I think basically you plug that on. I'm not really sure what the plus minus button's for. AC8, don't know, don't ask me. Let's try the light. The light is working, flashing, red flashing light. SOS is the last one. Which it is indeed doing. So excellent, it's all working. Let me just check some air comes out of here. So there we have it. Lovely repair. So problems with the LEDs, problems with the build, problems reassembling it, and ultimately it turned out to be the voltage regulator. So once again, checking voltages proved its worth, just the regulator. Unfortunately, I didn't have a TO92 regulator, 7805 regulator, but I did have a TO220, and strangely, it just managed to fit in the holes, just managed to fit on the board, and it's just physically bigger with more current capacity, and the repair is done. So there we go. I'll give that back to my friend, who probably doesn't really want it back, but he can have it, and it works again, and all is well. So I hope you enjoyed that. If you did, don't forget to like, subscribe, leave some comments, and of course share it with your friends. And I'll see you soon. Bye for now.